Question 5, we've got some more graphs to draw, so I'll start by drawing my e to the x graph. There's an e to the x graph. And the gradient of an e to the x graph is beautiful, it's just the e to the x graph again. But this time I want to do an e to the 2x, so everything is going to get half the distance here, like this, all of this. That point there is going to stay the same. All of these are getting half the distance there, and so we're getting a graph that looks like this. So it's still whooshing, it's still got exactly the same shape, but this is a y equals e to the 2x graph. And what's the gradient of that one? Well, it's going up twice as quick, and so that is y is 2e to the 2x, because it was going up twice as quick. The transformation for that one there was a stretch times by a half in the x direction, and state a link between the transformation and the gradient of each graph. So because we stretched times by half, the gradient got 2 times bigger. Let's try another color here then. So this time here we're going for the e to the minus x graph. So this is the one that goes down like this. So this time the gradient is the exact opposite of what it was before. So this is minus e to the minus x is what dy by dx is going to be. Sorry, that should have said dy by dx there. This time here we've done a reflection in the y-axis. And the reflection in the y-axis has made the gradient negative. And the last one, what colour should we do that one in? That one's going to be in black. So we've got e to the x add 4, so it's that red one. We're moving it up 4 places like that. And you'll notice that this graph here and this graph here are just translated up. So the gradient for this one here is exactly the same. The gradient of that one is just e to the x. And that one there, we have done a translation of up 4, so 0, 4. The gradient has stayed the same. Of course, you know when you differentiate a 4, it just disappears, and that's what's happened here. The gradient has just, the plus 4 has had no effect on the gradient.